Hi, and welcome to the third of 3 videos for section 10.4. Previous 2 videos we were looking at what? We were looking at addition, subtraction, scalar multiplication, and using that to solve equations. In this video, we're looking at multiplication of matrices. So it's not scalar multiplication. We're not just taking 5 times a specific matrix. We're taking 2 matrices and multiplying those matrices together. Explaining the process is a little bit tricky. So I'm going to kind of write out definition-wise what we do, and then I'll show you an example, and once you see the example, it's kind of a little easier to follow than trying to figure out the verbiage of it. So, first, if we multiply A times B, the number of columns in A must be the same as the number of rows in B. So for example, let's say that A is an M by N matrix. The only way I can multiply it by a matrix B is if it has N rows. And let's just call it K columns. It doesn't have to be the same as the rows of A. But what's important, if I'm going to multiply these, this has to be the same. And my result is going to be the outside variables, M by K. So if A and B have the same number of columns to rows, the result is going to be an M by K matrix. And then here's the wording of it. So to get the C entry with position ij, so whatever row, whatever column, so to get the Cij entry of A times B, we multiply and add the ith row of A by the jth column of B. And again, when we look at an example of this, it tends to be a little easier seeing what's going on than trying to interpret that information there. So, let's look at an example. Let's say we want to multiply, and let's let A equal 1, 3, -1, 0. And B is -1, 5, 2, 0, 4, 7. So A is what? A is 2 by 2. B is what? 2 by 3. So unlike addition and subtraction, they don't have to have the same dimension. But what they do have to have the same is the inside values. And they are 2 and 2, so that's fine. My result, so when I get done with this, I better end up with a 2 by 3 matrix. Result should be a 2 by 3 matrix. So the product is as follows. So let me rewrite this. 1, 3, -1, 0. negative 1, 5, 2, 0, 4, 7. So what I'm going to do, as it says here, I'm multiplying the ith row, 1, 3, by the jth column, negative 1, 0, to get the 1, 1 position. First row, first column. So what I do is 1 times negative 1 plus, and then I start moving around. That's why the number of rows, the number of columns and the number of rows, the inside values, have to be the same, because I'm just multiplying along as I go. So 1 times negative 1 plus 3 times 0. Then for the second position, 1 times 5 plus 3 times 4. And then the third one is 1 times 2, so this one times that value, plus 3 times 7. Now do the same. So this was the 1, 1 position, so it's row 1, column 1. This is 1, 2, row 1, column 2, and so forth. So now that I need the second row, first column, I need the second row of A, the first column of B. So negative 1 times negative 1 plus 0 times 0. Do it again, move over to the next column. Negative 1 times 5 plus 0 times 4. And then lastly, negative 1 times 2 plus 0 times 7. So now I have to go ahead and do all these calculations. So negative 1 times 1 is negative 1. 3 times 0 is 0, so negative 1 plus 0 is negative 1. 5 times 1 is 5, plus 3 times 4 is 12. 5 plus 12 is 17. 1 times 2 is 2. 3 times 7, 21. 2 plus 21 is 23. Negative 1 times negative 1, positive 1. Plus 0 is 0, so that's 1 plus 0. This is negative 5 plus 0 times 4 is 0, so that's negative 5. And negative 2 plus 0, negative 2. So that is the product of the matrix A times B. So let me give you a note here. Note, and this is unlike regular multiplication. So while matrix multiplication is associative and distributive, it is not commutative. So what this means is, in regular multiplication, 2 times 3 is the same as 3 times 2. I can switch the order, it doesn't matter. That doesn't work with matrix multiplication, right? Because A times B gives me this value. But what if I tried to do B times A? Well, B is a 2 by 3 matrix. A is a 2 by 2. These guys don't match, so I can't even perform this multiplication. Even if they did match, the results might not be the same because it's not commutative. The order, you just can't switch them and have it still work out. So, let's look at another example. Let me have you guys try this. So let A equal 5, 7, negative 3, 0. Let B equal 1, 2, 9, negative 1. So find A times B and find B times A if you can. So go ahead, hit pause, try to calculate these values or these matrices, come on back, see if you got the right answer. All right, welcome back. So first let's do A times B. So I have what? 5, 7, negative 3, 0 times B, which is 1, 2, 9, 1. Well, first of all, it's a 2 by 2, 2 by 2. So 2 by 2, 2 by 2. So middle numbers are fine, and I'm going to end up with a 2 by 2 matrix. So I have what? 5 times 1 is 5. 7 times 9 is 63. Then 5 times 2 is 10. 7 times 1 is 7. Negative 3 times 1, negative 3. 0 times 9, 0. Negative 3 times 2, negative 6. 0 times 1, 0. So if I simplify this, what do I get? 5 plus 63 is 68. 10 plus 7, 17. Negative 3 plus 0, negative 3. Negative 6 plus 0, negative 6. What did I do? Oh, this should be negative 1. Sorry. So this should have been 5 minus 63. Wait, no. Let me double check it. So 5 plus 63, that's fine. 10 minus 7, this should have been a minus 7. Negative 3 plus 0, negative 6 plus 0. Okay, so this should have been a 3 up in this position. So 68, 3, negative 3, negative 6. So I didn't have that negative sign in there. So hopefully you did and you got that matrix right. How about B times A? So I'm switching them. So now B is 1, 2, 9, negative 1. A is 5, 7, negative 3, 0. Same process. So 5 minus 6, 7 plus 0, 45 plus 3, and 63 plus 0. So that gives you what? It gives you negative 1, 7, 48, and 63. So even though we could do multiplication A times B or B times A, we didn't get the same results. So there you can see again, commutative, not the case with matrices. So the last example here. So let's let A equal 2, negative 5, 0, 7. And B is 1, negative 3, 0, 2, negative 1, 3. So again, find A times B and find B times A if you can do any of them at all. So go ahead and hit pause, give it a try, come on back, let's see how you did. All right, welcome back. So first, can we do A times B? Well, that's a 2 by 2 matrix. This one's 2 by 3, the middle numbers match, that's fine. So we get what? 2, negative 5, 0, 7. And then 1, negative 3, 0. 2, negative 1, 3. So we get 2 minus 10, negative 6 plus 5, 0 sorry, 0 minus 15. Then the bottom row, 0 plus 14, 0 minus 7, 0 plus 21. So that gives us negative 8, negative 1, negative 15, 14, negative 7, 21. Yep. How about B times A? So now we have 1, negative 3, 0, 2, negative 1, 3, and what do we have here? 2, negative 5, 0, 7. So this is B, this is A. So we have what? We have a 2 by 3 matrix here. Here we have a 2 by 2. These guys are not the same, therefore it cannot be done. So we say that that matrix is undefined. Cannot be done, undefined. So that's it. That's the end of video 3. That's the end of the videos for section 10.4. Come on back. Get close to wrapping up the chapter here. 10.5, 10.6, 10.7, and then you guys are done. So we'll see you in the next set of videos.